Okay, we're going to be adding some fractions today entirely in algebra. This really depends on you being able to add fractions with numbers yourself already, and if you can't do that, just pause now, practice that skill, and then come back when you're ready. So you should know that to add fractions, we care about the denominator a great deal, and we need a common denominator. Here we've got denominators of AC, which means you already have a common denominator, so we know that our answer is going to be something over AC, and here we got 3b added to 2b, which gets us 5b's all together, and that's a very straightforward case of adding fractions. We have a common denominator, so we add the numerators, job done. Slightly trickier is something like this. Where it might take a little bit of thinking working out to work out what the common denominators are. Try and think of factors here and what's missing. So this left-hand denominator has a d and an f in. This right-hand denominator has a g in, which wasn't there, and it has a d squared, which wasn't there. So we need to get an extra d and a g over here, and we need to get an extra f over here to make those match. So we're going to multiply this side, this top and bottom numerator denominator by 1, and that 1 will be dg over dg. So that gets us 3dg over d squared fg. And then this right-hand, sorry, that should be a subtraction there. And this right-hand denominator hasn't got any f's in, so you can multiply top and bottom by f to get 2f squared over d squared fg. And now these are the same, so our final fraction will be out of d squared fg. And subtracting terms when they're not like in algebra is very straightforward. You just write them. Job done. Then we get on to the more interesting stuff. We have to start noticing factors that might be hard to spot. Things like 2 over 9l plus 6 plus l over l plus 2. Now the common denominator here isn't necessarily immediately obvious. So, in fact I've got that slightly wrong, this should be a 3. Sorry, wrong question, that's the correct question now. Common denominator here isn't immediately obvious, but actually this left-hand denominator does factorise, and having it in its factorised form makes things simpler. So this right-hand one isn't going to change, and this left-hand one we're going to factorise. There's a common factor of 3 here, which gets us 3 lots of 3l plus 2. So in fact we've already got this factor here, the same in both. 3l plus 2 is in both denominators. So all that's missing here is a 3. So this is going to be 2 over 3 lots of 3l plus 2 plus multiply this by 3 top and bottom, 3l over 3 lots of 3l plus 2. And now we have a common denominator, so that will become 2 plus 3l over 3 lots of 3l plus 2. And finally, the full mess, the full nasty, h over k plus 3 plus 4h over k takes 7. So common denominator here, in fact these two are factors fully factorised. The only way to get them to come together is to multiply them by each other. So our denominator is going to have to be k plus 3, k takes 7, so this left hand fraction, the k takes 7 was the new thing, so it's h lots of k takes 7. And our right hand fraction, the k plus 3 was the new thing, so it's 4h lots of k plus 3. So we've now got the common denominator, we can add these up, and when we do that I'm also going to multiply out the top, the numerator brackets. So this is going to be hk take 7h plus 4hk plus 12h. I'm not going to expand the denominator because, as we saw with this previous question, knowing what the factors are on the denominators makes things easier to deal with later. So this will usually be part of a bigger problem, except in exams where it's going to stand by itself. So keeping the factors of the denominator known is often useful, rather than having to refactorise it again, which might cause you extra work. So collecting terms on top, we have got some HKs. We've got 1 there and 4 there. We've got 5 HKs. And collecting H's, we've got -7 and 12. So we've also got 5 H's, which isn't what I got last time. Negative error, that's why. This is correct. And that's going to be k plus 3, k takes 7. And just like having factors on the denominator is useful, it can be useful on top. So I'm going to factorise this 5h out. So we get 5h lots of k plus 1 over k plus 3, k takes 7. And that's probably the neatest form for this fraction, although other forms are correct too. The trick there, or the thing to spot, is how to find these common denominators, which is actually the same for adding fractions normally. Sometimes the common denominators are easier to spot than others, and sometimes you might not spot the lowest one straight away and things will have to cancel later. But I hope that helps. Enjoy!